In this video, we're going to go over some of the basic ideas of data structures and kind of an overview of some of the data structures we're going to be covering this semester. Okay, so let me start sharing my iPad screen. And we can go from there. There we are. Now we got it. Okay. Okay, so again, data structures, what are they? So data structures, they're a way to organize data. So that's what we're going to do. So we're going to organize data of some sort. So data is just information. Okay, in a way that makes us easier to deal with. Okay, so the things that we're looking at, the dimensions here, is going to be being able to get data. So the retrieval of the data. How can we store things so we can get it back easily? Okay. The storage itself, just a more efficient, easier way, the storage of the data. Okay. We want to be able to iterate through the data, go through one by one, see what's there. We want to be able to, in some cases, to search for items in the data. Not always, sometimes yes, sometimes no, okay? And the main thing, we want to have increased efficiency of our code when dealing with data, okay? One of the issues we have in any college class that you take is that you're probably not going to be dealing with anywhere near the data that you would in a real world situation, okay? So with the data here, we're really looking at balancing. Things in computer science are almost always a balance, okay? You're going to balance between the how flexible it is in terms of data access versus efficiency. And the efficiency is either of time or of storage. Okay, so those are the questions that are going to come up. Okay, so let's talk about some data structures you probably already know. Okay, so in the C++ world, okay, I assume you've hit arrays before. Okay, so arrays typically are just going to be, you know, a listing of items there, okay, that we can have. Okay, arrays in C++ are of a fixed size. So you have to declare them to be a size of 100, size of 10, whatever, okay? They allow random access, which means I can go right to, if it is A, they start at 0, 1, 2, 3. So if I do A sub 3, I can go directly to what I want. I don't have to go anywhere else, okay? They also have, you have to have the same data type or homogeneous data type in the entire structure, okay? So you should have seen that already before. I think it's all you've probably seen in C++. Python has a bunch, okay? Because Python is a language with a lot of built-in ones. If you've taken Java or C#, you're going to see a bunch there as well. But you may have covered things such as lists or dictionaries. Even strings are a data structure in Python, things you can iterate through, okay? So as far as where we're headed, okay, the ones we're going to be creating, there's some broad categories here. I'm going to give us just a brief overview of things, okay? Probably the most important is the linked list. And again, you're going to get much fuller descriptions with actual code examples when we get to them. But a linked list, a couple of ways to draw it. I tend to draw it this way. You're going to use a struct for most of these data structures to create this node. Okay, the node is going to contain some kind of information, okay, and then a pointer. Okay, so it can point to another node in a linked fashion. Okay, so you can go through as many of those as you need. Okay, we're going to put this backslash when we're done. Okay, these are stored in memory somewhere. That when a new node's created, gets put into memory. We keep track of it through some pointer, which we can call root. Okay, or sometimes called head. Okay. So that's all we have to keep track of. We can then get there. Okay, so these have sequential access. You don't know where any one is except the first one, unless you happen to place other pointers. Sometimes there's a pointer to the last one if you needed that for some reason. But you have a pointer to root. You then have to go through to find what you're looking for. Okay, so it's sequential access, not random. The size is unlimited up to the system memory. Okay, so you can fill up your whole memory with these. Okay, it also has the same data types. Okay, so as opposed to an array, it's this unlimited size that works pretty well for us. It also, an array, I didn't say this, but it's in contiguous memory. Which means you have to have a big chunk available where the linked list can use whatever memory you have. Okay, so those are kind of the advantages between the two. They can be as big as you need, all that. The disadvantage is that you can't get directly. If you want to get to the 10th item in a list, you have no idea where that's at. You have to start at the first one and keep going until you find it. Okay, but at a much lower cost. There's also less to keep track of in a linked list. Okay, other kinds of data structures we're going to talk about. We have stacks. So the way a stack works, and the way I like to think of it, if you've ever been in a cafeteria, has a stack of plates. Okay, so the counter's up here. This is a hole in the counter. Okay, so the first plate that you pull out is the last plate that you've added. Okay, so if you add this plate, okay, and then you go to get a plate, that plate's one you're going to get. Okay, and then the one before that, and the one before that, and finally the last one to come out is the first one to go in. So we're going to call this a first in, last out. Okay, and it turns out this is pretty handy. One way it gets used in computer science, if you're making function calls to call other functions. Okay, so you call an F1, okay, that then calls an F2, then calls an F3. Okay, that would be a stack. So when F3 is done, it's the first one to be shut down. It was the last one to be added, then the F2, and then the F1. Okay, so stacks come in handy for things like that. It also allows us to reverse things. If you shove things into a list and then pull it right back out, you've reversed your list of things. Okay. In a similar way, we have a queue, which is Q-U-E-U-E, which has a lot of extra letters for sure. Okay. With a queue, it's going to be a first in, first out. Okay, so if you're doing something where you're like doing print jobs, well, then the first one to come in probably is the first one you want to leave. Okay, and queue is a word in England for a line. So like you would have a queue at the movie theaters. The first person there should be the first person to go. Okay, so we'll talk about queues for sure. Okay, then we have the idea of a hash table as a data structure. With a hash table, there's a couple of things you have to have. You create this table, has a certain size, whatever the size is. So this has a size of 7, okay? You then create a hash function. So let's say I'm storing integers here. I want my hash function to take an int, okay? And it's going to return the int mod 7. Okay, so it's all going to go between 0 and 6. Okay, so if I would enter a 14, it would give me a hash value of 0 since there's no remainder, and then we would store that 14 there. Okay, if I did a, I don't know, a 10, okay, that would have a hash value, the remainder would be 3, and I would store that there. Okay, so the idea being that once you have the value and you have a hash function, you can go directly to what you want. Okay, and we'll talk about lots of issues related to that, but that's the basic idea. Okay, then we have trees of various sorts. Okay, in particular, we're going to look at binary trees. Okay, so a binary tree is going to have a node. Okay, It's going to store some info. It's going to have 2 children, hence the binary part. Each of those can, but don't have to have 2 children. Okay, so that's okay. So binary trees are a little tricky to program, but turn out to be very useful, okay, in modeling problems. Okay, so we'll get some examples of that. We have a binary search tree, which is a particular tree that has the characteristic that the left child, so if we're talking about here, this is the left child, is going to be less than the root as far as the value that it stores, and the right child is going to be greater than the root, okay, for the whole tree. Okay, again, we'll get more into that later. Okay, we have the idea of a B tree. A B tree is kind of an index, so it has nodes that contain more data. Look like this, okay, and this allows you to have multiple links out of there. Okay, so if you have some value X here and some value Y there, this link is going to be less than X. This is going to be between X and Y. Okay, this is going to be between Y and Z. This is going to be between Z and W. This is going to be greater than W. Okay, so it's a way to make a shorter tree and to get places quicker. Okay, then the last data structure we're going to talk about is a graph. You may have seen a graph in mathematics. A graph consists of a series of vertices. Okay, so vertices, in this case, we're going to have 1, 2, 3, 4, and 5. And then we have a series of edges, which are connections between those. So if we have that, our edges would be a 1, 2, a 2, 3, a 2, 4, and a 4, 5. Okay, there's lots you can do with a graph. Okay, so this was a relatively quick kind of an overview of where we're headed. So we're going to talk about each of these data structures in more detail and code them up. We're also going to talk about sorting and searching and things like that. Okay, that's the basic idea. So if you have any questions, make sure you let me know.